In this video, we will be showing the utilization of different properties in solving the numericals of Laplace transform. For this, the first numerical that we are having is find the Laplace transform of the signal xt is equal to minus t e to the power minus 2t ut. Now, as we can see that this function or this question xt is equal to minus t e to the power minus 2t ut comprises of various elements. Firstly, it has a minus t in it, then it has a e to the power minus 2t, and it has a value of ut. Now, since we already know that Laplace transform of e to the power minus at ut is equal to 1 upon s plus a. So, applying this value, we can, if we apply minus or we can apply 2 in place of a, our Laplace transform of e to the power minus 2t ut will yield us 1 upon s plus 2. Now, according to the differentiation in S domain property, we have that if it is minus t into xt, then it will be equal to dxs upon ds. Now, in this numerical, we can term that this term as a whole we can take at one time. Okay, so in place of xt, I can put e to the power minus 2t ut, and we already know that the Laplace of e to the power minus 2t ut is 1 upon s plus 2. So if I am multiplying it with minus t, it will yield in differentiation of xs. That xs is nothing but the Laplace transform of e to the power minus 2t ut. Now it will give us the differentiation with respect to s of 1 upon s plus 2. Now 1 upon s plus 2 happens to be the Laplace transform of e to the power minus 2t ut. Now this will, if you are going to differentiate 1 upon s plus 2 with respect to ds, then it will yield minus 1 upon s plus 2 whole square. Now this is the solution of my question. Secondly, if you are given a question that find the initial and final values of xs is equal to s plus 5 upon s square plus 3s plus 2. Now according to our initial value theorem, we have the initial value, that is x0 is equal to limit s tends to infinity s xs, which gives us limit s tends to infinity s into the value of xs we can put over here, that is into s plus 5 upon s square plus 3s plus 2. Now it will yield us limit s tends to infinity s square plus 5s upon s square plus 3s plus 2. Now if we divide the numerator and denominator by s square, now if we are going to put the infinity over here, then it will be infinity by infinity. Now so to remove that, we can utilize this, that by dividing numerator and denominator by s square, we can have 1 plus 5 upon s upon 1 plus 3 upon s plus 2 upon s square. Now if we put this infinity in place of s, this factor becomes 0, this factor again becomes 0, this factor again becomes 0. So our initial value comes out to be 1. Now to determine the final value, we have the formula that x infinity is equal to limit s tends to 0 s xs. Now if I put the value of xs in this, then we have s into s plus 5 upon s square plus 3s plus 2, which is equal to limit s tends to 0 s square plus 5s upon s square plus 3s plus 2. Now if we are going to put the value of s is equal to 0 in this equation, it will yield 0 upon 2, which gives us the final value, that is 0. Thank you.